All right, guys, Pierluigi here. I want to show you this morning. I want to show you my latest project. That's a funny project, actually. It's a Pong engine, Pong, the classic arcade, probably the oldest video game ever produced. So I just thought it would have been nice to design an engine that could play Pong, as I was not very strong. Uh, Even when I was young. But yeah, I took the chance to do both a geometric based engine, as you will see, and an AI one based on essentially data saved during the games of the first engine. Okay, so let me show you briefly how it works. Okay, so the first engine is very simple. It's actually both engines rely on the fact that there's a there's an external Pong executable that is captured. The Windows is captured and the objects are also captured and the contour is is detected by OpenCV2, which is an incredible library, by the way. The algorithm is very simple. When the ball is traveling to the enemy side, is just the paddle just follows the ball uh, y coordinate, while when it comes back, I calculate based on two consequent readings of the ball position. I calculate and predict the straight line. Therefore, I can predict where it will hit, uh, where it will end at the x of the paddle, at the x coordinate of the paddle, and then of course I save the the CSV for the network training. The neural network is a very simple network. It has the inputs, ball and paddle position, and then three layers, three dense layers. The first one is 128, and then 32 and 32. I made several experiments, but then I found that this setting is was quite good in terms of fitting the The AI-based engine, of course, doesn't use any geometry knowledge. Of course, it just uses the same inputs as the other engine. So it gets the window and then the contours, but then it passes the position to the network and gets the keyboard action uh, to play externally the Pong program, just like the other engine. So the geometry engine proved to be much stronger. It could beat the Pong CPU in both in easy, normal, and hard mode. It loses badly in the nightmare mode, which is really a nightmare. The AI is not very strong, but at least it goes reasonably well in easy mode. Most of the time, it wins. In the other modes, it loses all the time. I guess that's because of the very simple nature of the very simple nature of the network and probably the data. I have the feeling that I could probably uh, train it using maybe also speed, but I don't know. We'll see maybe in the future. So let me show you now how the geometric engine works. So I will start the engine. Uh, so first I start the program, the Pong program, as you will see. That's the program. Then now I'll start the macro. Just let me make sure. Oh, okay, I still have the other engine on. So let me comment, and then let's enable the geometric engine. So I can after I'll show you some code. Not a big deal, but Okay, this is the CV2 capture window, so we will see what the engine does in terms of calculation. So we can start with the normal mode. As you can see, when the ball goes in that direction, the paddle moves just up and down, following the ball, while in this direction it tries to predict with the slope. Now we got a goal from the CPU, but hopefully we will equalize soon. Hopefully, as you can see, it plays very well, even when the speed of the ball goes a little bit crazy. So I'm very pleased with the geometric engine. Uh, Again, we get some goals sometimes, but most of the time uh, the engine works. That's a nice goal. And yeah, of course, I don't want to show you the entire game. Would be very boring. But as you can see, it plays quite good. So let's have a look at the AI. Maybe let's have a look at the last rally. There you go. Okay, so let's have a look now at the AI engine. At least we scored another goal. Okay, so let me comment in the code the geometric engine, and let's get the AI one. Of course, I pre-trained the network. I pre-trained the network, and now I've enabled. So let's try. Okay, so as usual, that's the Pong program. Now we start again the Python macro. Same thing in terms of acquiring the window and the contours, but you will see that there's no line. Don't expect the miracles by the AI engine. As I said, is not extremely strong, but as you can see, sometimes it misses very easy ball. I don't understand really why, but in general, as you can see, is not too bad. Again, even in this case, it seems to be very to swing up and down sometimes, but yeah, most of the time it doesn't go too bad. Let's have a look at the other, maybe a few more exchanges. These are not too good actually, but yeah, that's a good one. Okay, yeah, this behavior is not very clear to me because the fitting was very good in terms of result, and was not overfitting. So even with the portion of the data not used for the training, it was quite good. Anyway, so trust me, most of the time it wins in the with the in the easy mode. As I said, in the other modes, it's constantly beat it. Maybe this time it will lose. I don't know. Anyway, so I want to show you some code now, just to give you an idea of how both the that was nice. Okay, so let's have a look at the code now. Let me see if I can show you maybe a little bit more. No, okay, that's probably okay. So this is the main the main loop. Let me move it here so I can probably see it better. Okay, so the main I'm sorry, I went to the wrong. Okay, the main loop is quite easy. Apart from some initialization, we look for a window called Pong, not very robust, but just for the demo, let's say. Then we look for the uh, for the frame. We grab the windows using MSS. I found this library, which is very good, and and then we find the contours of the object. There's a function that detects object. See, very simple. Find contours. That's a CV2 function. Very nice. Very powerful. And well, okay, some handling here, and then if we get the ball, of course here, put back the geometric engine, and we control the paddle. The paddle is the control of the paddle is actually very straightforward, because we get the coordinate of the paddle and the ball, of course, and then if the and then we take two consecutive ball x reading, check for division by 0, and then we calculate the m and the q of the straight line, do some approximation, and then I draw the line on the frame. If there are some problem, of course, I use the ball as a target, and then this is to check that the ball is going in this direction or in the other direction. So again, if the ball is going in the other direction, we just follow the ball. There's not much sense in following the line. So of course, if we use the line, we use the predicted the target calculated by the straight line equation, and then we clamp a little bit, and then the action is very simple. If we are below where we should be, we go up by pressing the I don't know why this program has W to go up and S to go down, and of course the other way around. If not, we just release the keys just to make sure that there's no issues with the keyboard, and then we save the CSV for the for training the other engine. And as you can see, the data very simple: ball position, paddle position, action up and down, and the reward. So 1 or -1, 1 if we hit the ball, -1 if we miss it. So that's basically it. That's the right paddle. All right, let me show you the. Okay, that's the control function for the neural network. Very straightforward. We just get the paddle, the ball, and then we prepare the state for the model, and we just get back the action from the model. And again, if the action is 1, we go up, otherwise we go down, and so on. So very simple. The model, we get it at the beginning. That's the one saved by the training action. Training it super simple. The model is this one. I've tried to minimize usage of complex library. I've only used TensorFlow and of course NumPy and so on. So training, very simple. So again, I hope you enjoyed the video, and feel free to get in touch if you want to have more details. Have a good day. Bye-bye.